Some planets may have a wider range of life than Earth, according to new study August 25, 2019. A new study indicates that some exoplanets planets found outside our solar system may have better living conditions than Earth itself. Some planets may have a wider range of life than Earth. Illustration of how an exoplanet with life might look like. Researcher Stephanie Olson said of this new finding, "This is a surprising conclusion, which shows us that conditions on some exoplanets with favorable ocean circulation patterns may be better suited to support more abundant or more active life than life on Earth." The discovery of exoplanets accelerated the search for life outside our solar system. The enormous distances to these exoplanets mean that they are effectively impossible to reach with space probes. So scientists are working with remote sensing tools such as telescopes to understand which conditions prevail on different exoplanets. Understanding these remote observations requires the development of sophisticated models of climate and planetary evolution that will enable scientists to recognize which of these distant planets may harbor life. Presenting a new synthesis of this work in a keynote lecture at the Goldschmidt Geochemistry Congress in Barcelona, Dr. Stephanie Olson, University of Chicago, describes the quest to identify the best environments for exoplanet life. NASA's quest for life in the universe is focused on the so-called habitable zone planets, which are worlds with the potential for liquid water oceans. But not all oceans are equally hospitable, and some oceans will be better places to live than others because of their global circulation patterns. Olson's team modeled likely conditions on different types of exoplanets using Rock 3D software, developed by NASA's Goddard Institute for Space Studies (GISS), to simulate oceanic climates and habitats. Different types of exoplanets. She informed, "Our work aims to identify the exoplanet oceans that are most capable of hosting globally abundant and active life. Life in the Earth's oceans depends on outcrop uplift that returns nutrients from the dark depths of the ocean to sunlit portions. The ocean where photosynthetic life lives. More resurgence means more nutrient replenishment, which means more biological activity. These are the conditions we need to look for in exoplanets." The team modeled a variety of possible exoplanets, and was able to define which types of exoplanets have the best chance of developing and sustaining thriving biospheres. Dr. Olson further reported, "We use an ocean circulation model to identify which planets will have the most efficient resurgence and thus offer particularly hospitable oceans. We find that higher atmospheric density, slower rotation rates and the presence of continents lead to higher resurgence rates. The Earth may not be ideally habitable, and life elsewhere may enjoy a planet that is even more hospitable than ours. There will always be limitations to our technology, so life is almost certainly more common than detectable life. In our search for life in the universe, we must target the subset of habitable planets that will be most favorable to the globally active large biospheres, because these are the planets where life will be easier to detect, and where undetections will be most significant." Dr. Olson notes that we do not yet have telescopes capable of identifying appropriate exoplanets and testing this hypothesis, but says, "Ideally, this work will inform the telescopes designed to ensure that future missions, such as the proposed LIVOIR or HABX telescope concepts, have the right capabilities." Now we know what to look for, so we need to start looking. Commenting, Professor Chris Reinhardt, Georgia Institute of Technology, USA, said, "We expect oceans to be important in regulating some of the most convincing remotely detectable signs of life in habitable worlds, but our understanding of oceans beyond our solar system is currently very rudimentary." Dr. Olson's work represents a significant and exciting step in our understanding of exoplanet oceanography. The first exoplanet was discovered in 1992 and currently more than 4,000 exoplanets have been confirmed to date. The nearest known exoplanet is Proxima Centauri b, which is 4.25 light-years away. Today, much of the search for life in exoplanets focuses on those in the habitable zone, which is the range of distances from a star where a planet's temperature allows oceans of liquid water critical to life on Earth.